Name is Brent from Achieve Engineering. We do a lot of work with Arctic Foundations of Canada. We are a consulting engineering firm, and Arctic Foundations is the fabricator, installer, and supplier for thermosyphons across Canada. Thermosyphons, I'm not sure how many of you are familiar with thermosyphons, but thermosyphons, the whole purpose is that they move heat. They move heat from a place where it's colder to a place where it's warmer, or a place where it's warmer to a place where it's colder. That's what they do. A thermosyphon system is a simple, robust, reliable system to move heat. A thermosyphon has no moving parts, and it consumes no energy. In its simplest form, that's what it is. It all sounds too good to be true, and I thought this about 10 or 15 years ago myself. So before we get into it, it's best for everybody to understand how a thermosyphon actually operates. A thermosyphon is essentially a steel pipe that's filled with refrigerant. A thermosyphon transfers heat using a two-stage or a two-phase process. On the bottom of the thermosyphon, where it's usually warmer, and the top of the thermosyphon where it's colder, what will happen is that heat flows into the bottom of the thermosyphon through the soil. As the heat flows in, it warms up the refrigerant within the pipe. As it warms up the refrigerant, that refrigerant boils. As it boils, it turns from a liquid into a gas. Now the gas is going to be lighter than the liquid, so it's going to flow up to the top just because of the change in density. As the refrigerant flows to the top of the thermosyphon, it's colder outside than it is down below, so therefore now the vapor is going to condense and turn into a liquid. When it turns into a liquid, it flows down the outside walls of the thermosyphon and goes back down into the evaporator. It's essentially perpetual motion powered by a temperature difference. You need about 1/10 of a degree difference between the bottom part and the top part for the thermosyphon to become active. That is Thermosyphons 101. When I say they're simple, all it is a welded steel pipe full of refrigerant. Part of it usually above grade, part of it is buried. There's many different variations on a theme, but that's the fundamentals right there. On the right side, you'll see a sloped thermosyphon. You take the vertical one, you bend it a little bit, now it becomes a sloped thermosyphon. But the operating principle is exactly the same. Typical thermosyphon applications, Arctic Foundations of Canada will typically install these underneath a building. The whole purpose, again, is to prevent the heat from the building from going down into the permafrost, degrading or destroying the permafrost below the building, which will eventually happen over time, and then your building is going to sink, your building is going to shift, your permafrost is gone. One of the other big applications of thermosyphons is you can use them to build a freeze wall. Now, a freeze wall you can do many different things with. You can use it in the mining environment for a dam, for a frozen dam, so you can have water on one side and an open pit on the other. A frozen dam is going to be much less permeable to the water than a non-frozen dam. You can also use a freeze wall to separate a contaminated area from a non-contaminated area. There's many different applications for a thermosyphon. In Nunavut lately, Arctic Foundations has installed thermosyphons in 6 hockey rinks throughout the territory. What the government of Nunavut is getting is essentially free ice in the winter, where before they were having trouble making ice up until December, January. Now they have trouble taking the ice out come April or May. Free refrigeration powered by Mother Nature. Thermosyphons can be used anywhere. Arctic Foundations at their shop in Eli, which is just west of Winnipeg, had thermosyphons installed. They maintained permafrost in their back shop for over 10 years with no auxiliary cooling. So thermosyphons do work, and what you'll hear later is that the CSA has actually developed a standard that's out for public review right now around thermosyphons and how they work. Typically, Arctic Foundations will rely on owners, on engineers for applications. If there's an application out there, chances are we can make a thermosyphon work if you need to move heat. No. How do you go next? There we go. One of the basic layouts or arrangements of a thermosyphon is a vertical thermosyphon. As it's shown here, you have a pipe essentially bored into the ground, or you drill a hole, you drop the pipe down, you charge it with your refrigerant, and you have a piece of pipe sticking above grade. In the bottom, it's going to absorb heat from the ground. It's going to create a frozen zone around that bottom part of the pipe, and above it, that's where that heat is going to dissipate. On the right, that would be what a typical freeze wall installation would look like with a collection of thermosyphons. Now, if we take that vertical pipe, we put a little bit of a bend into it. Now we have a sloped thermosyphon. Typically, these would be used underneath a building. It's exactly the same operating principle. The only difference is just a slightly different arrangement. On the left side here, what you see is a typical design for what would happen under a building, where you have a floor slab, a layer of insulation, and a non-frost susceptible fill. The intent of a thermosyphon system underneath a building is to maintain the thaw depth within that non-frost susceptible fill, which will happen in the summertime. In the wintertime, the thermosyphon becomes active and, again, refreezes that pretty darn quick. Over the years, what we found is that buildings were getting bigger, buildings were getting more complicated throughout the territories. The sloped thermosyphon system just wasn't working anymore because of the grade that we required over the length of the thermosyphon. Installations were becoming cumbersome, installations were becoming much more costly, so Arctic Foundations developed a flat loop thermosyphon. In this installation, all the evaporator piping is at one level. So when the contractor goes to do the installation or prepare the site for Arctic Foundations to come and do the piping, it's much easier to do, saving time and saving a whole bunch of money. The operation, again, is exactly the same, where the evaporator piping is all piped into a radiator or a collection of radiators and provides the ground freezing. What can happen is if you don't get enough refrigeration capacity out of a passive thermosyphon and you need additional cooling capacity, or if you need to speed up construction of a project. A lot of times what we've seen is the contractor wants to start construction as soon as the boat arrives, as soon as the boat arrives to drop off the material in the community. So that means starting construction in October. But we need to freeze the ground before the contractor can actually start. A lot of times Arctic Foundations will go in March or April, install the ground freezing system, install the thermosyphon system at that time so that they can start the construction of the superstructure and the foundation and the piles and the whole 9 yards come October. To do that, it's not cold enough outside, obviously, so Arctic Foundations developed a hybrid thermosyphon. Now, what a hybrid thermosyphon is essentially you take a refrigeration package, which is a compressor, a condenser, and all that good stuff, and you pipe it up to a thermosyphon. So if you need to freeze the ground quickly, or if you need to supplement the cooling capacity of an existing thermosyphon system, you can install a hybrid thermosyphon. Essentially what that involves is putting a small compressor package, typically like this, in a group of thermosyphons. You can operate it for as little or as long as you need to. You can operate it for 2 weeks, you can operate it for 2 months, you can operate it for the summer and then shut it off in the winter. It's all up to you. If you need to freeze the ground back quickly, this is a great alternative. One of the really important things about thermosyphons is how do we know they're working? With each installation, Arctic Foundations will install a grid of temperature sensors horizontally and vertically on the site. All the wiring is terminated back in a control cabinet. We highly recommend, and it's noted in the CSA standard, that these have to be checked on a regular basis, probably every 4 to 6 months at a minimum. This can be connected to an automatic dialer as well as a satellite communication system if the owners request it. When thermosyphon systems are designed, what we do is we go through a one-dimensional and a two-dimensional heat transfer analysis of the building for that specific location and those specific soil conditions. This is some of the output that would be typical for a building that we're working on. One of the products that's not typically used in Canada is what's called a thermopile. What a thermopile is it's a thermosyphon where you have a relatively small amount of the radiator sticking above grade, and it's a load-bearing thermosyphon. It will take the load of a building, it'll take the load of a transmission tower, it'll take the load of a pipeline. The way it works is that the evaporator in the ground builds up a freeze ball around it as it's working. Then the top portion, which is typically relatively short compared to a flat loop or an inclined plane thermosyphon, that will stick slightly above grade, and then your building will either sit on there, a pipe rack can sit on there for pipelines, or in the case of the picture here, it's actually an electrical transmission tower. So in that case, the power company was having trouble with shifting the foundation. 3 thermopiles were installed, supplementary cooling, or supplementary steel rather. The tower was supported. After everything was frozen back, the tower was chopped off from the existing foundation. It works very, very well. These are used a lot in Alaska. Arctic Foundations in Anchorage does a lot of these types of installations, typically used where you have high ice soils. At the end of the day, this is what the building typically looks like if you have a flat loop or a sloped thermosyphon installation. Doesn't really detract from the building at all. You just have some white pipes and you'll see them walking around Yellowknife. Permafrost adaptation, you guys can see that, you guys can read this just as well as I. The big thing to take away is each system is specifically designed to suit the application to meet the user requirements. Global climate change is considered in each and every design. Thermosyphons have a long history. They're robust, reliable, simple. They've been in use for over 40 years in the US and Canada. They work, and the CSA standard is one more verification of that functionality. That is Thermosyphons 101.
Thank you, sir. Questions?
I was just wondering, have you had any failures, and how would you fix the pipe leaks?
There was one failure at the hospital in Nunavik that's relatively well published. At that failure, lessons were learned. It was a material failure of pipe from the factory. That type of pipe is no longer used, and that situation has not happened since.
All right. Any other? Yeah, please. 2 questions. Wow.
This time it's a very general question. I just want to have your general opinion, because a lot of the permafrost is already rather warm, between 0 and -2, and it's going, with coming climate warming, it's going to disappear in some places. So if we put thermosyphons under buildings, new buildings, for example, in those places, and eventually we will end up cooling the ground to maintain the buildings in, let's say, in 20 years or 35 years from now. How do you see that? Do you see a kind of multiplication of buildings on thermosyphons in places where there won't be any more permafrost in 30 years? Or I just want to know what you think of that. Well,
that's a great question. I personally, I'd love to see I'd love to see thermosyphons in every building in the north, but that's not a reality. It depends on the soil conditions. There's geophysical considerations. There's logistical considerations. There's a whole bunch of things that enter into the design of the foundation. So it's a great question. There's a lot of opportunities for thermosyphons, and frankly, if you're building a $20 million building, putting some thermosyphons in may not be such a bad idea to protect that investment.
All right, Maren, and then Billy.
Hello.
Hi.
I was just wondering, in your last slide, it says that these thermosyphons are mostly used in Canada and Alaska. And I was wondering how extensively they're used across the circumpolar north. And if they're not, then if there's something else that's commonly used across the rest of the north.
Well, thermosyphons have been used worldwide. During the last break, Bill Watt of Arctic Foundations and I were talking about a job that they did in Russia. The technology was developed in Anchorage by Arctic Foundations and was licensed to Arctic Foundations of Canada. The technology is so simple and so robust, it just makes sense. Russia has it. I don't know what they're doing in some of the Scandinavian countries or Greenland for that matter. Again, it depends on the soil conditions. It depends on a whole bunch of other things that influence the decision makers.
Okay, thanks.
Billy?
Hi, Billy. Archie Aklavik. Just a question, looking for a solution. I don't know how many people have been to Aklavik, but our power lines are staggering all over the place. And there's a couple that are leaning really nice, about ready to fall over. What would you suggest for a solution?
Oh, we need about 1 million thermosyphons. I don't know. That's something that we can certainly, I'd love to talk to you about it after, when we both have some time. I think that would be a good, potentially a good opportunity.
Yeah,
but it has to be a right fit for everybody.
Between the roads getting soft and power poles leaning over, it's
Right.
we're going to wait for a power line to fall over before we decide to do something. Kind of prevention.
That would be a bad thing. I'm no electrical engineer, but I think a power line falling over would probably be not
yeah,
so good.
especially you got 120,000 volts hitting the ground. I mean,
Yeah, that would
I guess
not
we got to
be
wait
good.
till we zap somebody before we
Sure.
decide to do something about it.
Well, let's get together at a break.
All right, thank you, Brent. I think that
you.
we'll wrap that for now.